Okay, so we are to the last lesson in Unit 5, and this lesson is pretty simply named Using Congruent Triangles. So what this lesson will do is this lesson is going to pull together all of the triangle congruence theorems that we learned in the last few lessons, and we're going to be applying them. So for the first example, we're showing how we can use congruent shapes, congruent triangles, to find the length, or the width, sorry, of a river. So it says, the figure shows how a surveyor can measure the width of a river by making measurements on only one, and that should say side at the end. That's my fault. Made a typo. So we're studying the figure and explaining how we can find the width of the river. So the width of the river we can't measure directly, so we got to use something called indirect measurement. So if we look at these triangles, all right, we are looking at a measurement we can make, DC. The length of that. We can create a right angle, and we can create these two segments. Now, the idea is that if I create two triangles like this, these triangles will have to be congruent. So, as long as I measure my segment and I create a right angle, it really doesn't matter what the angle is right here by point C, because when this segment, and I'll trace it with green, when this segment meets this segment, the length of DE is the length of the river. And the triangles I create are going to be congruent by ASA. So it's seeing where we can assume ASA in this diagram. So we measure DE, which is congruent to AB. And AB represents the width of that river. And the reason we can do that is because triangle ABC is congruent to triangle DEF by angle side angle. So we learned about angle side angle in a previous lesson, and it's reviewing that. Because if we say that two triangles are congruent, that means we can assume that all of the corresponding parts are congruent. So I can assume AB and DE are the same length because I proved those triangles are congruent by ASA. So you can take measurements on one side to help you find measurements that you can't directly find for the other side or for the width of the river. So the main thing we're doing here is that we are looking at, in example 2, how to prove that a statement is true. So you're going to learn a statement talking about corresponding parts from our diagram, some things we know, some things we can assume. We can assume angle T is congruent to angle W, because that's marked. Okay, I can assume that TV is congruent to WV, because that's marked. The last thing I can assume is that, and I'm going to mark it, this angle right here and this angle right here are congruent. So I'm going to say, and I'm going to have to list them out with 3 letters. I can say that angle TVU is congruent to angle WVX, and that is because those are vertical angles. So it's remembering our definition of vertical angles from before. So what that means with these things being proven, that means that triangle TUV is congruent to triangle WXV by, and with all those things we can assume, they're congruent by ASA. That is the main thing to know, the way we can say that those relationships are the same. So in green, I'm going to mark what we can assume. We can assume that UV and XV are congruent. Okay? We can assume that they are congruent because corresponding parts are congruent. So UV is congruent to xv because corresponding parts are congruent. Okay? So if I say two triangles are congruent, their corresponding parts are also congruent. So it's taking what we can assume. We've got to be able to prove the triangles are congruent to each other by one of our theorems, and then use that to say corresponding parts are congruent. So in the next example, proving that TS is congruent to VR. TS and VR. So in this triangle, some things we can assume, all right? These triangles are right triangles, okay? Another thing we can assume, leg and hypotenuse we got to think about here because we've got right triangles. So leg RT is congruent to leg UV because they have the same little double marking there. Hypotenuse RS is congruent to hypotenuse UR. So these triangles, I would say triangle RST is congruent to triangle URV by, and that's going to be hypotenuse leg, because we have a right angle and we have a hypotenuse equal to congruent to a hypotenuse, a leg congruent to a leg. So those are congruent. So these parts, these segments, TS, I'm going to use 3 markings, and VR are congruent because corresponding parts are congruent. So the main thing in this is us remembering our theorems right here. This is the important part because that allows us to assume all of the corresponding parts are the same measure, that their corresponding parts are congruent. So in C, talking about things we can assume, angle J is congruent to angle M. JL and ML are congruent. Okay? JK and MN are congruent. So from this, it's going back to some of our theorems from before, but these triangles, I'll say JKL, triangle JKL, is congruent to triangle MNL by, and we've got a side, an angle, and a side. A side, an angle, and a side. So these are congruent by SAS. So that means these are congruent because they are corresponding parts. So the main thing is if things are marked as congruent, we can assume they're congruent. The other thing we've got to look out for is vertical angles. That's going to be another common thing where vertical angles may not be marked, but we can assume they're congruent because we've learned about vertical angles before. So that kind of concludes these notes. This is just one page, but this is mostly, this lesson in the unit is meant as like a review lesson of all of our theorems. So this is, I'm going to write this in blue. Remember our theorems. We've got ASA, SSS, hypotenuse leg, side, angle, side, angle, angle, side. Those are our theorems. Okay? Just remember, SSA is not one of our theorems. That's important to remember. So we've got to be able to kind of recognize which theorem is applied when. So this is, kind of think of this as your review for our final quiz in this unit. So you're going to have some practice. Remember to keep doing the quizzes and logging in with your name. And if the paper and pencil practice is something you prefer, let me know that, all right? The biggest thing with this is communication. You've got to communicate with me if you need something. I'm going to help you. I will set up Google Meets with you one-on-one if you need them. But just remember, if you log in at between 2 and 3 o'clock and I'm not in the meet, email me. I may be meeting with someone in person, or I may be making copies of something. So just keep that communication open, and we're going to get through this, all right?